Now let's start interactive concrete design. So first of all, we will start with normal concrete design. So for that, just click on new project, select a space, then take length as meter, portion it as kilometer. Press next, yes, and then select the add new option. Then finish. Now go to the geometry and select the run structure result option. Then select the model type as a frame model, select a brake frame here, and now give the length as 6, height as 9, width as 6 once again, number of ways along the length as 2, along the height as 3, along the width as 2 once again. Click on apply. So we are going to start with a small wave frame. Now click on the transfer model option, press yes to OK and OK. Now switch off the grid, then go to the general option, give the property. So define a rectangular section for beam and for column individually. So just give it as 0.25 is to 0.2. So it is for beam, and now 0.3 is to 0.3 for the column. Add it. Now select, go to the select option, beam parallel to X, beam parallel to Z, and now assign to selected beams, press yes, OK. Now select the 0.3 section, and now select the beam parallel to Y axis and assign it. So we have a column here. Now just go to the render view. Now you can see the render view. Here we have a column and a beam. Now go to the support option, create a fixed support, add it, provide the support here, assign it. So we have assigned a fixed support here. Now go to the load and definition. So just select the load case detail option, click on the add option, select the dead load and the title as dead. Now then select live load and give the title as live. Now add it. Now select the dead load option, add and give the sulfate, then member load. Let take wall of 0.250 meter, means 250 mm. So according to that, approximately the force comes as minus 15, and global y-axis, just add it. Take the floor load of a slab. So just take a slab of 150 mm or 6 inch. According to that, the weight comes simply as 3.75. Now give the maximum height as 9 meter, then press add. Now take a live load, add it, go to the floor load. For the building, for the residential building, it varies from 2 to 3, and for the commercial building it varies from 4 to 5. So just take it as minus 3 and give the height as 9 meter. Now press add. Those sulfate assigned to view, and UDL, select the UDL and select the beam parallel to X, select the beam parallel to Z, and assign to selected beams, assign yes. Now select the load case detail once again, add it, and go to the auto load combination, select the Indian code, general structure, generate loads, discard them, and then select one combination. So I am selecting here 1.5, add it. Now give the analysis command without print, close and analyze. Save. Now analysis is completed. Now go to the design option, select the concrete, select the code as IS456, select the parameter, So here are several parameters, so you can take only compressive strength and the yield strength of the steel. That's okay. Now define the parameters. So take the compressive strength as 25, because here it is a kilonewton per meter square, so provide 30, 1, 2, 3 and add it, and provide the steel strength as 415, 1, 2, 3, 0. Now add it, close and assign to view to both. Assign yes, assign to view. Okay. Now after that, give the command as design beam, design column and take off. Add it, close. Now select the design beam option, select beam parallel to X, beam parallel to Z, assign to selected, yes. Always remember, don't give the multiple commands of same type. So now, so select the design column, select beam parallel to Y and assign it, yes. Now after that, analyze. Now check the output, whether the beam and column are designed or not. So select the concrete design option in the result. So now check the result. As you can see, there is no warning message, so it means all the beams and columns are designed. So there are two warnings about floor one-way loads, so no need to correct this warning. It is a common warning. And next one is the concrete, because staad don't provide the takeoff of steel slab. It provides only for the beam and column. This is a restriction here, so just close it. Now finally we have completed the normal concrete design. Now go to the interactive concrete design. So what is the difference between interactive concrete design and normal design? There is a simple difference. In the normal design, staad used to design each column and each beam individually. You can see in the same continuous span, you can see the first span is designed individually and then second one is also. The design is similar, almost similar. You will get almost similar design for both. But what it does, it designed it individually. But in interactive concrete design, what we do, we design it in a combination. Means staad will assume these both beam in a continuous form as a single beam. Now you can see for the column also. Here what we see, bar size is 12, bar number 4. Same result. And here you can see the bar size is 16, it exceeded. So we never do such type of construction in which we provide 12 mm dia of bar in bottom segment, and for the top segment we provide 16 mm. We never do that. We always provide a same bar from top to bottom. So for that we do the interactive concrete design to make it as a single column, or to get a common design. So for just select the concrete design mode from here. You can go to mode menu to select the interactive concrete design option from here, and here is a short key of that. So just select it. Now you will get a different window here of a concrete design. You can see, you can minimize it. Here is a normal window and here is an interactive concrete design window. So first of all, go to the design layer, job information. You can provide the job information. There is not mandatory that you provide it. So just go to the envelope option, define a new envelope, name it as envelope 1. Now select the type of load. So if you want to go with a combination load, just check it, show combination only. If you want to go with dead and live load without factor of safety, so you can uncheck it and select dead and live. So I want to go with the factor of safety, so I am selecting here the combination load. Just select it and press OK. Now go to the member option to form a member. So what I do now, I will make a single member by after selecting each beam individually. So it makes a member only to a collinear beams or a collinear columns. So for that, what we do, set the elevation view or a front view. Now select all the beams and click on the member menu and click on the auto form member option. Now set the side view and then select the beam again, and again go to the member menu and click on the auto form member. Now after that, you can see here there are 3 rows of column and 3 rows of column are in at the length side and at the width side. So what you do, just set the front view and then select one by one individually and just click on the form member option. Here is a short key of form member, just click on it. So it gives you a message, only 3 elements used in member. So just press OK, again select it. Now you can see a warning comes here, element 45 is already part of a member and a cross symbol here. So it means there is no column behind it. So let's move to the next one and do the same thing for member. Because we have a 3 rows, so do it as 3 times. So we have got member list here. Now you can see. So here we have 18 beams and rest of other as column from 19 to 27, and each column member has 3 individual columns. Now just go to the, because here we have no slab, so just go to the group and brief and give a new brief here. So just give it as V1 as beam, select the code as IS456 and select the beam. OK. Now give the general information. So what is the general information is minimum cover of the beam, so 25, side cover is 25, bottom cover is 25. It is the minimum value of the cover, you can give it. Now select the concrete grade as 25. Now select the M25. Minimum reinforcement spacing, which is 40 mm. And then if you want to go with the check for 13920 means the code for the seismic design, you can check it and select the envelope for it and the gravity load case, which here you can select the load case with which you want to go. Now just go to the main reinforcement and select the top bar criteria, means the die of the bar. Minimum size of die of the bar 8 and maximum size of die of the bar you can take it as 16. Link anchor size 8. Minimum gapping 32 mm. Now side bar criteria, if in the beam side reinforcement is provided, so what should be the dia there, so you can select it from here. and give the yield strength 415. It is already selected. Now give the shear reinforcement, that is the value of the stirrups, parameters value of the stirrup. So how you want to design the beam, centered line support or a column face, means face to face. Shear bar criteria, so it is a dia of the bar, minimum dia of the bar. It is the legs of the stirrup, you can select it from here. Minimum spacing between them, so it is provided here as 40 mm. It is a minimum, you can change it. And the shear bar type, so it is a grade of the shear stirrups bar. Now you can select link is closed or it is open, so just it is by default it is closed. Now just press OK. Now second brief for the column, so select the column here, OK. And now select the M25 here, grade, steel bar grade, main reinforcement means main bars 415 steel bar, and for the ties, so it is 250. Now minimum size you can give it here 12 or whatever you want to give it, 12, 20. Minimum size of the stirrup, it is 8 here. Now go to the column factors, so you can select the effective length factors, y axis 1, z axis 1. It is a factor of safety again. Now slenderness limit, so staad calculates the slenderness ratio, that is K. How it can calculate, so you can provide a value type of calculation here. So if you select always 1, it doesn't calculate any slenderness, it keep it 1. And if you set it calculated, set as calculated, so it will calculate. Now select the member load case as combination load. Never forget to select the member load case here. Now select the new design group as beam. Give the design group name beam, and again second design group as column, and select a column here. Okay. Now set the front view and select all the beams like this. Now check whether all the beams are selected or not. Give a right click on any of the beam, just click on the add member to design group option and select the design group. So select the name as beam and click on the add option and press OK. Now after that just give a double click on the G1. So you can see here is the analysis section and here is a design section. Now set the front view once again and select all the columns. So now you can see all the columns selected now once, and now give a right click any of the column, add member to design group option and select the column. Now press add option and press OK, and you can click on the G2 and now you can see the group. Now after that go to the concrete member, set the group name as beam and just click on the design here. So in the status bar you can see designing member 6, 7, 8. So all the beams are designed. Now you can see the result here. So it is a structure 1 beam summary. Here what is here? Member number 1. You can select it from here and it displays here. So how many span is it? It has 2 span, first span and second span. Now in the both span the hogging and sagging ratio for the main reinforcement is okay, shear bars are okay, means the stirrup is are okay. Span upon depth ratio, it is a must criteria for the beam, so it is also okay here. Now go to the next structure beam span. Here what you can see in the span tab, for the member 1 the length of the first member beam is 3 meter and for the second span is 3 meter. Now hogging is 2.5 and sagging 2.5. It is a cover, it is in centimeter, means a 25 mm, and for the side reinforcement for the side face cover is 25 mm once again, and the link size is 8 mm. Now if you select the support tab, you can see the support at the member 1. Now for the member 1 add node 4, node 5, means 3 nodes here, first, second, third. 2 are the end nodes, N4 and N6, and 5 is the center node. So you can see the fixed support is assumed here. You can change the support from here. You make it as simple support, fixed support, or no support. You can change it. Now after that, go to the main layout for the member one. So you can select the member from here also. Now for the member one, here it is a main reinforcement. Now you can see in the top diagram, you can see you can drag this flag from here to there, and you can drag this seek bar also. So in the top diagram, you can see the main bars here. These are the main bars. If you right click on it, you can see the plan view from the top of the beam. Now if you click on the show encourage, it will show you a encouraged reinforcement, means the curtailment. Now in the mid diagram, you can see the bending moment diagram. Now here is a section. At what section you want to see it, you can give the value here. Suppose you want to see it at 1.5 meter. Just give it 1.5 meter and click on set. So here you can see 2 bars are there and 2 bars in the bottom. Now you can see somewhere it has third bar also in the top segment. So how you can check it? You just drag this flag to this. Now you can see third bars comes here in the mid span. Now here is a first layer reinforcement, second layer, bottom first layer and bottom second layer. So there is a only layer 1 reinforcement for the top and bottom on both. So now you can see this bar criteria. The first main bar, it is of 16 mm dia and it is from the 0.001 meter to ending distance is 5.99 meter. Now you can see the second bar is started from the 4.1 meter and ends it is started from 0.01 meter and ends at 5.99 meter, and the third bar started from 2.850 meter and end at 3.150 meter. Now same for the bottom also. Now go to the main reinforcement here, main reinforcement tab. Now you can see span, once again beam support span. So here it is a length, cover, size, length, the same support. It is the same table as you saw in main layout. Now here it is a main reinforcement table. Now you check this table for the hogging and for the sacking. Here is a distance, means it is for the member 1 now. You can change it for the member 2, member 3. So it is for the member 1 here as of now. So you can see the section, how many sections here. So you can count it 1, 2, 3, 4, 5. Now see the span. So first span is started from 0 to 3. E means end, S means start. Now you can see the moment, area of steel required here also in the hogging, and bottom layers and top layer reinforcement. So 2 bars of 12 dia. What is the area of reinforcement provided? 226 mm square. And what is the requirement here? 341. Now in the top layer it is 2 bars of 16 dia, and what is the requirement area of steel provided here? 402. Now go to the sagging. You can check the sagging also. For the sagging, what is the main reinforcement provided here? You can check. So the in the hogging tab, the green color value is for the sagging, and in the sagging tab, the green color value is for the hogging. Now check the shear layout, means for the stirrup. Now you can see the first here is an unequal distribution. You can see in the first segment 8 dia of stirrup, it is provided at 50 mm center to center distance, and here it is from 75 center to center distance. Now here it is as 50 mm center to center distance, and it is a shear force diagram for the beam, and you can see the section also, section diagram. Now here the shear reinforcement main table. Now so you can see the beam is divided into the section, and here is the shear force at each section, shear stress value, and area of steel required. Now here you can see a beam is divided into a 6 zone, and here is the value of start of the zone and end of the zone. Number of legs means 2-legged stirrup. The size of the stirrup is 8 mm dia, and spacing between them is 5 cm means 50 mm, and area of steel required provided is 101 mm square. And here you can set the schedule. You can just click on the schedule option and select the paper size, drawing scale, format as DXF. It goes to the AutoCAD, and just press OK to save it, and save it anywhere, and after that open it in AutoCAD. Now go to the summary option once again, summary tab, and select the column group 2, and now click on the design. Just click on the design. So now you can see some columns have been designed and some is not okay. So M19 is designed, M21 is designed. So corners column are designed, but the center one and the mid column is not designed here. So M20, M22, M23, M24. Sometimes it happens. So for that what you do, just change the size of the column. So for that what you do, just save it and close it. And now go to the normal concrete design, define a separate section here. So give it as 0.35, 0.35, use the square column and just add it, and set the top view and select the column which is not designed in interactive concrete design. So you can select it like this and assign it. Now after that what you do, just analyze it. So whenever it happens that any design, if you found any design is failed in interactive concrete design, just save it and close it, and go to the normal concrete design, change the section size, analyze it, and after analyzing it, go to the interactive concrete design once again. And now you can see in the design layer, members, group and brief, just click on the G2 option. Now you can see the analysis section is changed. It comes from where? It comes from normal concrete design. Now just go to the concrete member, select the column, and click on the design option once again. Now you can see all the columns have been designed. So it is a interactive concrete design. So it is completed now.